Ask an AI agent to do something simple on a computer. Find the right page, change one setting, fill one form, and submit it. In chat, it sounds like it understands the task. On the screen, one scroll, one pop-up, or one wrong button can derail everything. That gap is the real story. Today's AI can explain software better than many people, but using software is a different skill. So this video is not asking whether AI agents are impressive. They are. The question is why they still get lost in ordinary digital rooms. The first trap is a belief that sounds reasonable. If a model can reason about a website, it should be able to operate that website. But a website is not a paragraph. It is a changing state machine with buttons, menus, hidden forms, loading delays, permissions, and consequences. Mind2Web was built because older web agent tasks were too narrow. It collected open-ended tasks from real websites across many domains. That matters because the hard part is often not language. It is finding the right clickable thing inside a noisy, unfamiliar interface. WebArena pushed the same idea further by building functional websites where agents had to finish realistic internet tasks end to end. The result was not close to human reliability. The best GPT-4-based agent reported in the paper reached 14.41% success, while humans reached 78.24%. That number is not a permanent ceiling, but it tells us something important. Sounding correct during the task is not the same as completing the task. For a normal user, this is the difference between an agent saying, "I found the refund form," and actually submitting the refund correctly. The second trap is time. Computer tasks are long-horizon problems disguised as small steps. An agent observes the screen, decides what to do, clicks or types, waits for feedback, then has to update its plan. Each step can be almost right. The problem is that almost right does not compose very well over 20 or 50 actions. Click the wrong tab, misread a disabled button, miss a changed field, or fail to notice a modal window, and the plan starts drifting. Humans recover from this constantly because we have years of interface habits. We know what loading feels like, what danger looks like, and when to back out. AI agents often have to infer that from screenshots, HTML, accessibility trees, text descriptions, and a fragile memory of what just happened. That is why the desktop is harder than the web alone. A computer is not one app. It is a messy ecosystem of apps, files, windows, menus, and conventions. OSWorld was designed to test that broader problem. It includes 369 real computer tasks across web apps, desktop apps, file I/O, and multi-application workflows. In OSWorld, humans completed more than 72% of tasks. The best model in the paper completed 12.24%, with failures tied to GUI grounding and operational knowledge. GUI grounding means connecting an instruction like open the exported file to the actual thing on screen. Operational knowledge means knowing what the software action really does. Those are not tiny details. They are the difference between understanding the goal and controlling the environment. Knowledge work makes this even sharper. WorkArena looks at browser agents doing common enterprise software tasks where state and permissions are part of the job. The paper found promise, but still a considerable gap toward full task automation. That is exactly the practical zone where companies want agents to work. In office software, partial completion is dangerous. A task can look done while the wrong customer, ticket, date, checkbox, or approval path has been selected. This is why adding more visual overlays to an agent is not enough. The agent needs a loop that can verify what changed, not just describe the screen. There is a strong counterpoint. Computer use agents are real now, not science fiction. Anthropic's computer use beta is a clear example. Their launch described Claude looking at a screen, moving a cursor, clicking buttons, and typing text. It also called the capability experimental, cumbersome, and error-prone. Anthropic reported better OSWorld results than earlier systems, including 14.9% screenshot-only and 22% with more steps. But that still says early. So the sober view is not agents are fake. The sober view is that action reliability is now the bottleneck everyone can see. To get better, agents need stronger perception, better state memory, clearer recovery behavior, and verification that checks the world after every important action. The cleanest automation often skips the screen entirely. If a stable API can do the job, the agent should not pretend a cursor is smarter than structure. But screens still matter because real work is full of old tools, private dashboards, internal forms, and software that was never designed for agents. So the practical future is probably hybrid. Use structured tools when they exist, use computer control when they do not, and verify before crossing risky boundaries. They also need software designed for agents. Stable APIs, semantic UI labels, permission boundaries, and ways to ask for help before irreversible actions. This matters for safety too. A confused agent browsing a shop is annoying. A confused agent inside email, finance, deployment, or medical software is a different risk. The AGI implication is simple but uncomfortable. Intelligence in words is not the same as competence in the world. Using a computer is a tiny version of embodiment. The agent must perceive, choose, act, observe, and correct itself under uncertainty. That is why today's agents feel both magical and clumsy. They can talk like a strategist, then lose the battle against a drop-down menu. The next leap will not be only a bigger model. It will be a system that can keep its place, check its actions, and recover when the interface fights back. When that works, an AI agent will stop feeling like a clever narrator watching the screen and start feeling like a careful operator inside the task.